Problem number 2. The 6 strands isomerization of 1 to 62.3, 225, 58.2, 270, 50.7, 360, 43.5, 495, 39.9, 585, 37.2, 675. This is the time, okay. And for 30, yes, infinity. So these values are the percent. So this percentage of cis can be expressed as XA, which is the conversion of cis, which is 100 minus 6% over 100. These 6% values are the values which represents the cis remaining after how many seconds. So we can use this to solve for the constants of the rate equation if we convert these values into the conversion of cis, which is the XA. So the conversion of the 6% can be calculated as 100 minus 6% over 100. So calculating, I obtained these values. So for first order reversible reaction, we have an equation which is negative of ln 1 minus xa over xae equals m plus 1 over m plus xae k1e. So how is this equation derived? So for the reaction A are reversible, we have K1, K2. So let M be CR naught over CA naught. So we have RA, negative RA is equal to negative dCA over dt equals CA naught dXA over dt, which is equal to K1 CA minus K to CR based from this equation. Based from this reaction rather. So we have that RA is equal to dCA over dt equals K1CA minus K2CR. We can write this as CA naught minus CA x. We can write CA or express CA as CA naught minus CA naught XA, the conversion of A, and CR we can have the express this as M CA naught plus CA naught XA, since we let M as CR naught over CA naught. So we have an equation which is K1 CA naught minus XA minus K2 times MCA naught plus CA naught XA. So at equilibrium, we have dCA over dt equals 0. So we assume the reaction to be at equilibrium. So we have 0 is equal to K1 1 minus XAE minus K2 M plus XAE. So rearranging the equation, we obtain K1 over K2 equals M plus XAE over 1 minus XAE. So we can use this equation to substitute K2 here in this equation. So we can only have K1 in the equation. So substituting this equation to this equation, we arrive with XA over dt equals K1 times 1 minus XA minus K2, K1, since we changed it already, times 1 minus XAE over M plus XAE times M plus XA. So rearranging this equation to form integrating equation, for our integration, you have dxa over dt equals k1 times m plus 1 over m plus xae times m plus xa, and then combining like terms, we will arrive with combining like terms dxa over m plus xa times m plus xae equals k1 m plus 1 dt. So integrating, we will arrive with ln xae minus xa over xae equals m plus 1 over, I know this one, it must be remained here, so because this is constant, so we will arrive with m plus 1 over m plus xae k1t. That's how you arrive with this equation. So we already have this equation, and we have this value. You can remember that it is this one. This is, since consider the x equilibrium, but this is the percentage yet. We have to convert this first, and we already had. So we can use this equation to look for k1. So for it to be not complicated or just simple, I already solved this value, this one, and plotted with a t. So I got 0.7, 0.592, 0.511, 0.333, 0.282, 0.207, 0.135, 0.099, and 0.072 with their respective time. So what we do now is just plot this in the calculator and solve for it. I plot t versus negative ln xae minus xa. So would we select start. It is 3. We select this one, 2. So input the data. So plot the value of time: 0, 45, 90, 225, 270, 360, and then 495, and then 585, and then 672. Then plot the value of negative ln xae minus xa, which is the 0.7, ln of 159, negative ln of 0.511. after the data input, select red. So this is our slope. We get a slope where the slope is K1 over XAE. XAE, which is equal to 0.00335, and K1 is equal to 0.0335 XAE. Since we have already XAE, which is 0.7, K1 equals 0.0335 times 0.7. Remember this one, where the 6% is 30, and you solve it to convert it into XA, which is the conversion of our cis. So 100 minus 0.3 100 minus 30 over 100 is 0.7, and then K1 over K2 equals M plus XAE over 1 minus XAE we substitute the values. Yeah, this one results to 0.0233, and over K2 equals 0 plus 0.7 over 1 minus 0.7. So solving for this, we have K2 value of 9.986 times 10 to the negative 4, and box it. One. And the K1 was this one, K1. So we already have the two values.